Hello everybody, welcome into another lesson. So today we are going to talk about another application of determinants. You can use determinants to also determine if three ordered pairs are collinear or not. As we know from geometry, collinear points mean that the points all lie on one single line, that they're on the same line. So 3 points are collinear if and only if the determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1 equals 0. So you have 3 ordered pairs. Your first ordered pair goes in the first row with a default entry of 1. Your second ordered pair goes in the second row with a default entry of 1 as the third entry. And then your third ordered pair goes in the third row with a default entry of 1 for your third entry. Notice this looks very similar to the determinant for the area of a triangle. It is very similar because it's basically the same thing, only we don't have a plus or minus 1/2. We're just dealing straight with the determinant. That determinant has to equal 0 for the points to be collinear. If it equals anything, and I mean anything other than 0, the 3 points are not collinear. It is really that simple. So let's do some examples here. Alright, let's say, we'll do an easy one to start with. Point A is at the origin at 0, 0. We have point B at the point 1, 1. And then we have point C at the point 2, 2. So we need to determine, are these 3 points collinear? Well, let's take the determinant. So set up your 0 and 0 in your first row with a default entry of 1. Set up your 1, 1 in the second row with another default entry of 1. Take your 2, 2 in the third row with another default entry of 1. So there's your determinant to determine if, in fact, they are collinear or not. Well, I think it's a no-brainer. We want to use the first row because it's got 2 zeros, which means we're only going to have one 2 by 2 determinant to worry about. We'll have a coefficient of 1 for our third entry in the first row, and according to our coefficient matrix, we'll keep it positive. So literally, it's just going to be the determinant of that with the coefficient of 1 in front of it. Now let's scratch out the column and the row it occurs in. It'll just be the determinant of 1, 1, 2, 2. So let's see, 1 times 2 is 2, minus 1 times 2 is, that turns into minus 2, gives you a determinant of 0. So these are collinear. So since the determinant is 0, these 3 points are in fact collinear. They do lie on the same line. Let's do another example here. What if we have, alright, we have point A is at the point 0, 1, point B is at the point 2, 7, and then we have point C, which is going to be at the point 5, 5. So we need to determine, are these 3 points collinear or not? Well, let's set up the determinant. So first row, you'll take your 0, your 1, then a default entry of 1. Second row, take your 2, your 7, then a default entry of 1. Your third row, take your 5, and a default entry of 1. Well, row 1 has a 0 in it, so that's a no-brainer. We'll use the first row. So we'll start with that coefficient of 1 as the second entry in the first row. According to my coefficient matrix, I need to negate that 1. So it'll be negative of the determinant of whatever's left over. So now strike out the column and the row it occurs in. That determinant will be 2, 1, 5, 1. Let's rebuild this a little bit here. And then we'll Alright, let's rebuild this matrix. So, the determinant. Wrong color, dang it. I'm trying to keep it all the same color if at all possible. 0, 1, 1, 7, 5. There we go. Next, we're going to use this other coefficient of 1 in the first row. It'll be the third entry in it. According to my coefficient matrix, I keep it positive. So it'll be just plus the determinant of whatever's left over. So now, strike out your column and row that it occurs in. It'll be the determinant that's left over is 2, 7, 5, and 5. Okay. So now let's just take negative of this determinant. 2 times 1 is 2, minus 1 times 5. That turns into 2 minus 5. Plus we'll have this determinant. 2 times 5 is 10. Minus 7 times 5, that'd be minus 35. Which would be equal to negative of 2 minus 5, which is negative 3, plus that 10 minus 35 is negative 25. Well, negative 3 is positive 3, then minus 25. 3 minus 25 equals negative 22. So the determinant is not 0, it's negative 22, so these are not collinear. These 3 points, therefore, are not collinear since the determinant does not equal 0. I have about 4 more examples here. This also shouldn't be a super long lesson. Alright. Point A will be at 0, 2. Point B will be at 1, 4. Point C will be at 2, 6. So we need to determine, are these 3 points collinear? Well, let's set up our determinant again. So take your 0 and 2 for the first row with that default entry of 1. Then take your 1 and 4 for your second row with another default entry of 1. Then take your 2 and 6 for the third row with yet another default entry of 1. Well, good news is the first row has a 0 again. So let's go ahead and use that row. We can skip the 0 and go right to the 2. I have a positive 2 for my coefficient here, for my constant in this for the second entry of the first row, but according to my coefficient matrix, I need to negate that. So this is going to end up being negative 2 times the determinant of whatever's left over after we strike out the column and row in which it occurs. So the determinant will end up being 1, 1, 2, and 1. All right. Now let's rebuild this, and we'll have to just do one more determinant. Alright, so then we deal with that 1 in the first row. According to my coefficient matrix, I'll keep it positive. So that'll be plus the determinant of whatever's left over. So let's strike out the column and row that occurs in, leaving us a determinant of 1, 4, 2, and 6. Now we just have 2 determinants to evaluate. So, of course, negative 2 times, okay, 1 times 1 is 1, minus 1 times 2, that'd be minus 2, plus, all right, 1 times 6 is 6, minus 4 times 2, that'd be minus 8. So then we have negative 2 times negative 1 plus 6 minus 8, which is negative 2, which will end up giving you 2 minus 2, which gives you a determinant value of 0. So the determinant is 0, so yes, these points are in fact collinear. So we do, in fact, have 3 collinear points out of this, since the determinant is 0. Alright, what about if I took point A, which is at 6, -1, point B, which would be at 2, 2, and then we have a point C, which is at 4, 8. So we need to determine, are these 3 points collinear? Well, set up your determinant. So take your 6, -1, then the default 1 in the first row. Take your 2, 2, and the default 1 in the first row. And then take your 4, 8, and default 1 in this third row. The first, second, third row. Okay. No zeros to save us this time. But we have the third column, which is all 1s, so we can use that column at the very least. Start with your first one in the third column. According to the coefficient matrix, we should keep it positive. So let's figure out what the resulting determinant is by scratching out the column and the row which it occurs. The determinant itself will be 2, 2, 4, 8. Let's rebuild this determinant now. We'll move on to the next coefficient. Alright, let's deal with the second one of the third column. So +1 there, but according to my coefficient matrix, I need to negate that. So it's going to be minus the resulting determinant. So strike out again the column and the row in which that occurs. That'll give you the determinant of 6, -1, 4, and 8. And then we'll rebuild this one more time. Then do your third one in the third column. According to the coefficient matrix, it should stay positive. So now this is going to be the resulting determinant of whatever's left once we strike out the column and the row. So we'll have a determinant of 6, -1, 2, 2. So now let's just deal with our 3 determinants. So 2 times 8 is going to be 16, minus 2 times 4, which is 8, minus the next determinant. 6 times 8 is 48, minus -1 times 4, that would be plus 4, plus then we have 6 times 2, which is going to be 12, minus -1 times 2, that'd be plus 2. This would turn into 8 minus 52 plus 14. 8 minus 52 is -44 plus 14 is -30. Well, my determinant's -30. It's not equal to 0, so these are not collinear. These 3 points are not collinear. All right. I just got 2 more examples, then we're done. So point A, let's see, is going to be at the point, let's see here, 1, 4. Point B would be at the point, let's see, so if I'm doing that, that would be 2, -1. Then point C would be at what point this time? 3, -15 plus 9 is 6. All right. So we have here A at 1, 4, B at 2, -1, C at 3, -6. That should be at 3, -6. So we need to determine, are these 3 points collinear? Let's set up the determinant. So 1, 4, and then a 1, 2, -1 and a 1, and then 3, -6 and a 1. Alright, no zeros to save our hide this time, but we have the third column, which is all ones, so that should help us. So let's start with the first one in the third column. The coefficient matrix states that should stay positive. So it's just going to be the determinant of whatever's left over after we strike out the column in the row in which it occurs. That'll be the determinant of 2, -1, 3, -6. Alright, so there's the first one. Now, what if we do the next one here? Let's deal with the second one in the third column. This time the coefficient matrix states it should be negative, so it'll be minus the resulting determinant. So once again, strike out the column in the row in which it occurs. You'll end up having the determinant of 1, 4, 3, -6. Then you get one more. All right. Then we'll deal with that third one in the third column. According to the coefficient matrix, it stays positive, so it'll be plus the resulting determinant. So let's strike out the column and the row in which that occurs, and we'll figure out our resulting determinant, which would end up being 1, 4, 2, -1. All right, so now we have our 3 2x2 determinants to evaluate. So 2 times -6 is -12, minus -1 times 3, that would turn into +3, minus this determinant, 1 times -6 is -6, minus 4 times 3, that'd be -12, plus this determinant, 1 times -1 is -1, minus 4 times 2, that'd be -8. Okay, so -12 plus 3 turns into -9. -6 minus 12 is -18. Negate that, you have +18. -1 minus 8 is -9, which would end up giving you a determinant of 0. So yes, since the determinant is 0, these 3 points are collinear. So we have 3 collinear points since the determinant equals 0. Pretty cool. I got one more example and then we are done for the day. Alright, how about if A has the point 1, 3, B is at -2, 6, and then we have C, which is at -1, 1. Alright, so we need to determine, are these 3 points in fact collinear? Well, set up your determinant again. So take your 1 and 3 from point A, then a default 1 in the third column, then take your -2, 6, and then a 1, and then your -1, 1, and then a 1. There's your determinant to determine if these 3 points are collinear. We have no 0 to save us again, so I'm going to suggest we just use the third column. So we'll start with that first one in the third column. According to our coefficient matrix, it should be positive. So we'll just take the determinant of whatever's left over once we strike out the column and row that it's in. That's going to leave the determinant of -2, 6, -1, and 1. Alright, let's rebuild this determinant a little bit. Now let's deal with the second one in the third column. This time the coefficient matrix states it should be negative. So it'll be minus the determinant of whatever's left over once we strike out the column and the row. So strike out this column, strike out that row. The resulting determinant ends up being 1, 3, -1, and 1. Then we got one more determinant to figure out. Let's rebuild this determinant a little bit here. Now we're going to deal with the third one of the third column, which according to our coefficient matrix should stay positive. So it'll just be plus the determinant of what's left once we strike out, of course, the column and the row which it occurs, which will end up being the determinant of 1, 3, -2, and 6. Alright, let's do these determinants now. First determinant, -2 times 1 is -2, minus 6 times -1, that would end up being plus 6, minus your next determinant, 1 times 1 is 1, minus 3 times -1, that turns into plus 3, plus then you have this last determinant, 1 times 6 is 6, minus 3 times -2, that would be another plus 6. So -2 plus 6 is what? Positive 4. 1 plus 3 is 4, so this will be minus 4. Then you have 6 plus 6, which is 12, which ends up giving you a determinant value of 12, meaning these are not collinear points. Because the determinant doesn't equal 0, these 3 points are all not collinear. So that's it for this lesson. Next lesson, actually the next 2 lessons, we're going to deal with what's called Cramer's rule, which enables us to actually use determinants to solve systems of equations. Next lesson we'll use Cramer's rule on a 2x2 system. Then the lesson after we'll use it on a 3x3 system. So I hope everyone has a great day. Take care.